Okay, in this video, we're going to look at using prime factorizations to find the lowest common multiple, sometimes known as the least common multiple, always referred to as the LCM. Okay, so I'm going to use a factor tree method for 42. 2 times 21 gives me 42, circle 2 because it's prime. 3 times 7 gives me 21, circle 3 and 7 because they're both prime. And there I have my prime factorization, 2 times 3 times 7. Now with 48, I'll use the factor tree method as well. We'll do 6 times 8. They're both composite, so I'll look at 6 to be 2 times 3 and 8 to be 2 times 4. Circle all numbers except 4. They're prime. 4 becomes 2 times 2. The prime factorization for this number 48 becomes 2 times 3 times 2 times 2. Now, to find the LCM, I need to look at both prime factorization lists. In other words, the red prime factorizations for 42 and for 48. There's a 2 common to both lists. So what I do now is I look for the prime factorization which has the most amount of 2's. And it is indeed 48. It has 2 to the exponent 4 or 4 2's. So I write those 4 2's in my LCM number sentence. Now, is there any other numbers that are common to both sides? Yes, 3. There's a 3 on both lists. So because there's 1 on both lists, it really doesn't matter which one I use. So I take one of those 3's and I put that in the list as well. The 7 is left over on its own. So I can pop that 7 in there as well. I have to include it. Okay. Now, I'm going to go ahead now and I'm going to go ahead and do the multiplication part. I'm going to break it into, using parentheses, break it into easier chunks of multiplication. So that becomes 4. 2 by 2 becomes 4. 3 by 7 becomes 21. So now I'm ending up with 4 times 4 times 21. I would mentally do the 4 times 21 to be 84. Multiply that by 4 to get it to be 336. So the steps here are make your prime factorizations, look for numbers that are common to both lists. And if there's a number that is common on both lists, whichever one has the most amount of multiples, write that down. And then look for other numbers common to both lists, write them down once if they only appear once, and then use the total product to find the lowest common multiple. Let's do an example with 3 numbers. This time we have 16. I'm using the repeated division method to find the prime factorization. To be 2 times 2 times 2 times 2, or 2 to the exponent 4. 80, again, similarly, I'll use the repeated division method to find my prime factorization. In this case, it's 2 to the exponent 4 times 5. Now for 120, my prime factorization becomes 2 to the exponent 3 times 3 times 5. So now I have identified all 3 prime factorizations. I'm looking for numbers that are common to all 3 lists, and it's very clear that the 2 is common on all 3 lists. So I'll go ahead now and I'll study and see that 2 to the exponent 4 is the joint most amount of 2's on all 3 lists. I'll go ahead and I'll write that down in my LCM, 2 to the exponent 4. I'll look at the other values on the other prime factorizations. I see that there is a 5. It appears once on 2 of the prime factorizations, so I'll write that in once. That sorts that out. And there's 1 3, which I'll need to include as well. And now I can go ahead and do my final multiplication to find the product for the LCM for those 3 numbers. I'll do 5 times 3. My 5 times, or 2 to the exponent 4 becomes 16. I'll pair up 5 times 3 becomes 15. So I should be able to scroll down a little here. Okay. You can see that 16 times 15 gives us 240. Again, we identify the prime factorizations. We look for numbers that are common to all 3 lists. Whichever has the greatest number or value of that number, we write that down. And we account for all other values as well, piece them together, find our total to be 240 in this example. Okay, so the lowest common multiple for 16, 80, and 120 is indeed 240. So hopefully this example helps you understand what we're doing for least common or lowest common multiple.